Cybersecurity. It's a word that might bring up nightmares of things like software patches or firewalls. But what if the biggest vulnerability in your system is actually what's soldered onto the board itself? So at Microelectronics, I talked to a company that claims it has the world's most secure microcontroller, which is a really bold claim. So before we find out a little bit more about them, what actually is security? So security in electronics isn't just about protecting your data. It's also about ensuring reliable and safe operation of all of the types of devices that we see in our lives. And this could be anything from energy grids to medical devices or even cars. So for example, the last thing you want is your brand spangled Tesla Roadster's retractable door system to suddenly stop working because someone has decided to perform a cyber attack. So for design engineers, security isn't just an afterthought, it's also a fundamental design parameter. Every day, attackers become more and more sophisticated. A staggering 70% of cyber attacks take place due to what we call memory safety vulnerabilities. And this is a war that engineers are constantly trying to fight. The root of the problem begins at the hardware level. And this means the microcontrollers that we actually design our systems around. So traditional programming languages like C or C++ offer incredible performance, but they don't provide an inherent memory protection. Unless you happen to be or have a cybersecurity expert at your disposal, we're forced to rely on a couple solutions. And this can include software-based security measures, which can be bypassed by kernel-level attacks, constant software updates to fix vulnerabilities as they're discovered, or using memory-safe programming languages, which takes a lot of time and can be very expensive. These approaches are neither reactive nor are they preventative, and they really place the burden on you, who likely is already overwhelmed with doing everything else, to anticipate and put an end to every potential threat. Along comes SCI Semiconductor. So instead of patching software, SCI are disrupting the market by drilling right into the core of the problem, and that's the hardware itself. So I spoke a little bit with Hayden, CEO at SCI Semiconductor, to find out a little bit more.
So with SCI, as you say, we are trying to address the biggest issue that we have in the world today, which is cyber. It's in the news right now, whether it's Jaguar Land Rover or Marks and Spencer's or whomever. The problem is everything's breaking and everything is breakable. So we're looking to invert the way in which we do cybersecurity. So instead of having layers upon layers of software on top of our systems, which just slow things down and obviously don't work, instead what we're doing is we're bringing cyber on device and making sure that the software that we have running on the device runs safely, runs securely, and can be maintained for the long term.
SCI claims it has created the world's most secure semiconductor. But how are they backing up that claim? Well, SCI together with the University of Cambridge have developed CHERI. And quite like the red fruit, it has some sweet benefits. But these benefits are to cyber secure embedded devices instead of our taste buds. So Hayden describes CHERI in a little bit more detail.
The reality is we have cyber attacks today because our systems are complex and overly complex in many ways. So people find flaws in the software and they can use those to gain access and gain control of systems. We change that through this technology that we're implementing called CHERI. CHERI changes the way in which we do pointer calls and the way in which the memory works inside the device to enable us to lock down those devices at a much more granular level.
Low level, like actually sort of on the silicon itself.
Absolutely. We go all the way down to the most fundamental part of the device, which is called the instruction set architecture. And inside of that, and inside the way that the system actually works from a computer science perspective, we can actually make very rich security guarantees. We know exactly what will happen in all of the cases. And if something goes out of bounds, which is normally what happens in a software attack, we can lock that down. We can either stop it happening completely or we can raise an exception and handle it as part of the system flow.
CHERI stands for Capability Hardware Enhanced Risk Instructions. And SCI have built a family of microcontrollers called iSemi, built on the CHERI IoT platform as a lightweight implementation. iSemi processors have been designed for high-performance 32-bit embedded applications, with an architecture that supports efficient, fine-grained, hardware-enforced compartmentalization with safe object granularity sharing. And this delivers complete spatial and temporal memory safety guarantees that the hardware.
I just want to briefly tell you about this tiny green box. Now, I would call it the Swiss Army knife of electrical engineers, but others call it an all-in-lab tool, but its legal name is the Analog Discovery 3. Now, I recently made this YouTube video where I breadboarded some circuits to run the 83 through its paces. I checked out its voltmeter, its oscilloscope, its spectrum analyzer, waveform generator, network analyzer, and protocol analyzer, and I would highly recommend you check that video out too.
Phew. I mean, that's a lot of words. So tell me, how does it actually work? Well, iSemi microcontrollers enforce hardware-level memory safety. How? They divide memory into secure components and strictly control how that memory is accessed. So that isn't just a software sandbox, it's actually a hardware-enforced barrier preventing common memory-based attacks like a buffer overflow. So how does this differentiate SCI from other companies?
So how do you back up the claim that you're the world's most secure microcontroller? What makes you more secure than your competitors?
It's really a differentiation in approach. It's this understanding that the failure modes are mostly around software, and that's what we're dealing with. We're not trying to hide secrets. We are trying to protect our software and stop it falling apart. Now, we've had red teams from companies like Microsoft and Google, and we've had other organizations like the National Cybersecurity Center purposefully trying to attack the device. And to date, nobody's been able to break the security models.
So what does this actually mean for you? Well, the first big bonus obviously is better inherent security. So you can design with the confidence that an entire battlefield of security vulnerabilities has actually been eradicated at the hardware level. You also have reduced development costs, so you can continue using your existing C-based code bases with more confident security. And instead of spending your time and resources on finding and patching memory-related software bugs, you can actually focus your time on things you will probably enjoy a bit more, like soldering. You also have a faster time to market, so a more secure foundation will mean you can develop and test your products just that little bit faster. And as well as that, the designs you do make will also be more future-proofed. So this secure hardware platform means you can actually put your products to market and go to sleep without having nightmares of a crafty hacker in the year 2030 finding some memory vulnerability in your code. So Hayden talks a little bit more about some of the use cases.
There are basically a load of use cases, but to start with the simple ones, we think things like operational technology in critical infrastructure and industry. So you can think of things like water treatment plants.
Right.
We know sewage is discharged too much. People are trying to monitor that. A lot of systems have been pushed out, but they can't be switched on because they're inherently not secure, so bad actors can play with them. Similarly, in the national grid with energy, we know that the national grid needs to be refactored for EVs and for wind farms and for battery storage in homes. But again, until that can properly be secured, we really can't switch it on. For the same reason that most smart meters the last 2 generations have got a lot more functionality than switched on because they're open to abuse.
This demo that you've brought for us, just could you explain a little bit about what this is? I mean, it's a beautiful house.
It's a beautiful house. And it's a functional house, and it shows what we call multi-tenancy.
Okay.
So in a smart meter, for example, today, there is one owner of that, which is the energy meter company.
Yeah.
But we think that actually that should be a place where multiple companies can take data from. So in this case, you may have some policies which you as the homeowner are setting. What do you want to do with your energy? Do you want to be green? Do you want to be cheap? Do you want to have a bit of both? But the operator may want to see your usage and understand how that goes. But that data can't leak to other people because
it's a big security risk if it does, right?
Yeah. Are you at home? Are you on holiday?
Yeah.
And for example, the grid operator power gen, network power, may want to understand the stress.
Yeah.
You know, how many people are switching on the kettle after the football? So this allows us to have multiple tenancy on a single device, strong isolation with safe sharing. And in this one, for example, we can pretend that the wind is
Very strong.
blowing
There we
where we
go.
are. So maybe the wind is blowing, we can be capturing some of that energy, we can actually be pushing it back out to the grid, generating. We may have photovoltaic cells on our roof, and we may have a number of users, a number of lights on. So what does your energy consumption look like? And how do we trade that off so that we don't have a single national grid anymore? We have a number of microgrids which can consume and generate energy independently, bringing down the cost and ultimately enabling us to hit net zero.
So instead of having to play a never-ending game of software whack-a-mole, SCI Semiconductor is trying to fix the problem at the core with their iSemi microcontrollers. And what this means is you can build fundamentally more secure products faster without living in the sort of constant fear of that next big vulnerability. So if you'd like to find out a little bit more about them, there is a link to an article about the company in the description. And if you have any thoughts about this sort of hardware-based approach, or just anything you'd like to say, let us know in the comments below.